Okay, good morning, ladies and gentlemen. Today is Monday, April 6th, I think. God only knows what day it is these days, huh, kids? And we're going to be continuing on. I'm going to review pages 19 and 20, your homework on interpreting information on quadratic equations, parabolas, looking for key things like increasing and decreasing and roots and vertex and things like that. And then we're going to move forward and we're going to focus on some algebra as opposed to graphing, okay? And you'll see that when we get to it. We're going to be kind of skipping around and skipping some of the graphing portion. What you're going to find out is you're going to use the graphs or the calculator actually to verify your answer. But most times they're going to ask you to do the algebra. It literally says this on the Regents exam. Only an algebraic solution will be accepted. So if you do it on your calculator, good for you, but they may not give you full credit for that. So that's why we need to learn these things. We'll be going back to what we were doing last unit with factoring the trinomials. I know that some of you did pretty well on that. My concern is, ladies and gentlemen, that a lot of us did it by Googling the answers rather than learning how to do it. No offense. I'm glad you found some way of doing it. You need to figure out how to do it yourself. Okay. Off my soapbox. Let's see what we got going on here on page 19. And just checking some homework. And it says, given the quadratic function below, whose turning point is 2, -4, which of the following gives the domain? Domain is x. Interval for its decreasing. And decreasing goes down from left to right. You're going to take the x value, 2, and it's going to be less than 2. All right, it sounds weird. It looks weird because you're thinking, well, it should be x is greater than 2. No, it's x is less than 2. All right, if you did it in interval notation, it would look like this. -∞, comma, 2. And once again, rounded bracket because it doesn't include that bottom point. Okay, that would be interval. All right, and then you got lots of work on that next one. And if you have your calculator, it does make your life a little bit easier. But if you didn't have your calculator, we can still do this. We found the graph of it. I did that in the calculator and plotted all my points. There's my vertex, 1, -4. The range is from here up, so that's why it's y is greater than or equal to -4. The zeros are -3 and +1, once again in squirrely brackets. Then the interval where it's negative, that's where it's down below here. Okay, so that's -3 to +1. So you take those roots and separate them with an x and a less than and a less than. And we have the interval for this function increasing. That's this side of the function where the last one was decreasing. This is the other side. And then they got that average rate of change problem. I know some of you probably skipped over that. That's okay. It's just slope. Okay? Which by now hopefully you know is change in y over change in x. That is a formula that they give you on the Regents exam. And you just take your 2 points. They say from -2 to 4, so there's -2 and there's 4. And there's your y coordinates for those two. And you got to be careful. I actually messed it up the first time I did it. For some reason I put a 4 on the bottom instead of the 2. And that gives me a slope of 2. Because if you drew this line right here, from here to here, not bad. Okay, and did the slope on it, it goes up 8 and over 4, and that would also give you a 2. In fact, if you did that on your paper, that would suffice for that work. So if you can draw it out, that's perfectly legit. Okay, so let's take a look at page 20. Sliding on down. And same basic set of problems. Okay, actually it's a carbon copy of the one we did in class with a different equation. So our range is y is less than 9. Our domain interval for the function increasing, okay, that's this side of the function since it's a frowny, is x is less than 1. And then you can see that you take those coordinates, the 1 and the 9, that turns into your vertex. And draw the axis of symmetry, that's also right from your vertex. And then your zeros are just where it crosses the x-axis. And we talked about this the other day, that it is called zeros because that's where y equals 0, since y equals 0. All right. So, today, we're going to be talking about roots and finding the roots, only now we're going to find them algebraically. I'm going to show you one graphically to start with. And I think I filled in the blanks for you on your printout if you go to print these pages out. So if I didn't, well, that's what they are. All right, so you have the roots are the zeros. And it can happen, you could have 1, 2, or none. What do I mean by that? Well, it comes down and it just kisses the x-axis. Okay, that's called tangent, actually. It's a nice word for that. That would have one solution. Actually, it has two solutions, but it's the same number. All right. If it has two solutions, it looks like what we've been doing most of the time. Something comes down and goes back up. There's 1, there's 2. And then none, if you have one that does something like this, that has no solutions. It never crosses that x-axis, okay? And the solutions there are like, oh, I'm not going to go there. I was going to say somebody's friends. They're imaginary. They're like my friends, imaginary. All right, so imaginary solutions, and you'll be studying imaginary numbers a lot next year, so we'll get into that next year. All right, and I just did one graphically here so you see what happens. I just graphed this one, and you can see it touches the axis that one time at -2, so that's my root. Solution, same thing. Root, solutions, and zeros, all the same thing. One solution right here, and I filled in all the little boxes they wanted me to fill in. Once again, you could get all of this from your calculator, but that's what we got going on here. All right, so now let's see how we do this algebraically. So if you turn over to the next page, we will see this top problem up here. All right, and we're just going to do that factoring. Once again, when you're doing this, you start here with the y equals blah, 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 or f of x equals. You change the y to a 0 right there. And now we factor. I'm going to talk my way through some of the factoring just to review. These are fairly straightforward, but you get the idea. This tells me the signs are the same. Story time. This tells me they're both plus. I do x plus and x plus. And I need the factors of 4 that add to 4, and hopefully we know that's 2 and 2, 2 and 2. Okay, but now the next step on this, if this was last unit, we would stop right there and give ourselves a little pat on the back and say yay us. Well, now we have to take it another step further, and we have to set each one of those factors equal to 0. So I get x plus 2 equals 0, and x plus 2 equals 0. Now you're saying, well, that's supposed to be equal 0. You're saying, well, that's kind of silly, Mr. Douglas. Those are both the same thing. True, but I just want you to get the algorithm down so you know what to do. I subtract 2 over, I get x equals -2. Subtract 2 over, I get x equals -2. So as I said a few minutes ago, or a minute ago, that we have two solutions, but they're the same number, -2. So our solution is -2. Okay? So the next one, it says two solutions right there, kind of a hint that you will have two solutions here. So once again, we're just doing the factoring the way we have been. And this tells me that the signs are plus and minus. This tells me the big one's a minus. Okay? So I'm looking for the factors of 5 that have a difference of 4. Well, there aren't very many factors of 5. So if the bigger one's a negative, I'm going to have +1 and -5. And if I add those together, I get -4. Yay me. So I have x minus 5, x plus 1. Okay, and you could write it as x plus 1 and x minus 5. Same thing. The negative just has to be with the 5, the positive with the 1. And you t-chart it. Okay, that's our new step. We do x minus 5 equals 0, x plus 1 equals 0, and that's going to give us plus 5, x equals 5, -1, x equals -1. So my solutions here are 5, -1. Okay, so there's two solutions. So if we want to graph this, it will look something like this, obviously not to scale. It goes through -1, and it goes down, and comes back up through 5. So -1 would be here, and 5 would be there, which would mean that my axis of symmetry would be right in the middle of that at x equals 2. Halfway between -1 and 5 would be x equals 2. And if you really want to get technical on it, this vertex would be at 2, negative 9. You don't believe me? Put it in your calculator and see what you get. All right? Now, when you're doing this, you can go through this and get these. Notice how you got the negative and the positive. And it's just the opposite of right here. You have to remember that when you're going through these situations that when you do your factors, the roots will have the opposite sign. Because if this was a multiple choice question, one of your multiple choice results would have been positive and negative like this rather than this. You got to be careful about that. And then down the bottom, they just want you to check it in your calculator and get all the information. We don't need to do that right now. We just are focusing on our factoring. Okay? So that's what we're doing on page 22. And we're going over to page 23. And we're going to skip the top because we actually already did that problem a few pages ago. Don't know how that happened. Mr. Douglas wasn't paying attention. All right. And this is another 2 solutions, but this is a special case. All right, we have x squared minus 64. And if you think about it for a second, this has a special name. This is the difference of 2 squares. All right, technically 2 perfect squares. Okay, and we call that dots. And that means we're taking the square root of the first term, square root, x, x. One gets a plus and one gets a minus. Square root of 64 is 8 and 8. Remember to use your square root button. It's not going to be half of this. A lot of people will write 32 on this. And usually, if we had x squared minus 16, I would tell you that probably 25% of you guys would do 8 and 8. Because you like to divide by 2. I like to divide by 2 also, but that's not the right answer. All right, so then we do our t-chart once again. X plus 8 equals 0. X minus 8 equals 0. Once again, you're just basically flipping the sign, but you need to show a little bit of work there. Minus 8, x equals negative 8, plus 8, x equals 8. Squirrely bracket, negative 8, 8, squirrely bracket. Okay, and once again down the bottom was just a check. We're not going to bother doing the check. You could see it pretty straightforward if you wanted to do that, but it would just give you the same thing that the roots are at positive and negative 8. And actually, if you wanted to write it that way, you could do it that way as plus minus 8. Perfectly legit when you're doing these sort of things. All right, so that's 23. What do we got on 24? 24. This is the one that says no solutions. So let's pop that in our calculator so you can see what I'm talking about when I say no solutions here. All right, and I'll get myself a new, calculator because I don't know what I'm doing. All right, and number 2 for a calculator, and we're just doing x squared plus 1. Enter. There it is right there, right down the middle. But does it cross the x-axis? Nope, it doesn't. So if we went to graph this, it would look something like this. Be at 1, and then out 1 and up 1. Something like that, just real quick, down and dirty graph. Out 1 and up 1, out 2 and up 4. I get that. So you can see that it never crosses the x-axis, so there are no solutions. And that's what you say. You say no solutions or no zeros. Do not do this. That's wrong. That means 0 is a solution, but that's not what's going on there. All right. So let's see that algebraically. All right. So what do we do here? That same equation we had up on top. X squared plus 1 equals 0. We needed to solve that. We would subtract 1 from both sides. And that gives me x squared equals negative 1. And then you take the square root of negative 1. All right. And you say that x is equal to plus or minus the square root of negative 1, which technically is true, but the square root of negative 1 is imaginary. Let me show you, maybe. Turn the calculator back on again and get myself a new document. and enter, and no, and 1, and control square root -1, not -1. Notice how it says I. Well, I use this calculator with a student that I tutor, and he is in Algebra 2, so he needs to have imaginary numbers, and the square root of -1 is known as I, an imaginary number, okay? And those two are basically interchangeable. But if you didn't have it reset to be in imaginary mode, A plus BI mode is what they call that, it would come up and say non-real solution, okay? So that's what you're looking for there. All right. And I think this is the last topic for today. This is, if I give you the roots, what's the equation of the parabola, or how do I graph the parabola, okay? And this is the roots formula. So if you have roots that are P and Q, okay, so in this case, -4 and +2, how do you graph that? All right, so what you do, you plug it in here. First of all, you're going to assume, which is perfectly okay, they don't tell you anything different, you're going to assume that A is equal to 1. So A equals 1 unless they tell you otherwise. Bold differently. All right. We can graph our roots. We can go here, -4. I'm going to give myself a big dot and a big dot. All right. So here's what I know. I know that there's an axis of symmetry right in the middle. So if you count in, you can go 1, 2, 3. I know my axis of symmetry is going to be right there at x equals -1. All right. And I can write my equation now. I'm going to write it down and then I'll do it again. Okay, x equals 1, remember that's our A. Then for this one, I'm going to do x minus -4. And then I'm going to multiply that times x minus 2. Once again, notice that your equation that you're plugging into has minus signs. Kind of like the slope formula, it's change in y, so x minus x, y minus y. Well, we have the sign flip on this. This is very common when you're dealing with formulas, where over here it says it's a positive, but when you plug it in, you're going to do a minus sign with it. Now I'm just going to simplify it so you get x equals x plus 4 times x minus 2. Okay? Now to fill in the rest of this, you say, well, I could double distribute that and do all that. You don't need to double distribute it. If they ask you to write the equation, you're done. Okay? If you want to do that, you can, but if you mess it up, well, then they're going to take points away. This is a fine answer right here. This will give me the equation of parabola. If I plug it into my calculator, it'll give me the whole deal. If you wanted to double distribute it, once again, this is a fairly straightforward one. We get y equals x squared, and then the sum, 4 minus 2 gives me a plus 2x. 4 times -2 gives me a minus 8. And then I can fill in the rest of my parabola by putting it in the calculator. And bada bing, bada boom. And I could fill in the table and all that. My vertex is at -1, comma, -9. Okay. I think I want to do one more. Yeah, I didn't want to do this one, but I did it anyway, and that's okay. I'm going to show you this one because this one's not quite so nice. All right. All right, so here we go. We're going to plug this in, and I have 3 and -2, don't I? Remember what I did last time? I said, okay, so if I count my way to the middle, that would give me my axis of symmetry. If I do that here, it winds up being at x equals 1/2. That's not nice, is it? So this time I'm really going to want to use my calculator. So I'm going to plug this in to my formula, and that's going to give me y equals x minus 3 times x minus a negative, so it's going to be x plus 2. Everybody okay with that? I'm not going to multiply it out. I'm going to put that in my calculator because I need to find out that vertex. That vertex is not going to be a great number. All right, I'm going to show you how to do that once again on my calculator. And I go to a graph and 2. I'm just going to type in exactly what I have there, parenthesis with an x minus 3, close it, and I'm going to hit a times button. I'm not sure whether I have to or not, but I don't want to take a chance. X plus 2, and then close it. Either way it'll work. I'm pretty sure, but I think you want to put the time sign there. And there's my, hey, look at that, that's pretty. All right, and I can go to my table of values. If you look at your table of values, it looks like you have a double vertex. Well, you can't have a double vertex. It wouldn't be flat on the bottom. That doesn't make any sense. So let's go back over here and Control T to get rid of that. And now you're going to do menu, and you're going to analyze your graph with a number 6, and you want to find a minimum. We don't want to find the zeros. We already know the zeros. That's at 3 and negative 2. We want to find the minimum. Okay, so I'm going to choose 2, and that gives me my dotted line. I'm going to slide it over a little bit so I make sure I'm not on top of that. I'm going to click and drag. Please drag and click. And if you look at it, you have 0.5. Like I said, that's halfway between the negative 2 and the positive 3, and then negative 6.25. All right, so when I go to graph this thing, well, let's do a couple of things here. First of all, I'm going to put in 0.5 in the middle here and negative 6.25. I'm going to do 0 and 1, and they were at 6, and actually negative 6. And let me call back my table. And then when I do negative 2, no, 2 is at 4. Means that negative 1 will be at 4. And then we have 3 is at 0 and negative 2 is at 0. There we go. Now I can graph this thing, and here's my 6, negative 3, negative 6. Once again, just kind of bring it down and underneath there and back up. Not my best parabola ever, but you get the idea. But you don't want to do this. Okay, no flat bottom. No flat bottom. Okay, and our vertex, you want to state that because they ask you to. We're going to have, this is at x equals 1/2. It's a minimum, and then our vertex was at 1/2, comma, negative 6.25. Okay, so that takes care of that. Is there anything else I want to do here? Let me take a look. All right, I think I want to do 1 or 2 more factoring for you, and then I'll figure out what you got going on. All right, so page 26, and we're going to skip a little bit, I think. Set it equal to 0. Okay, now a lot of people get fooled with this one thinking it's a dots problem. You got a perfect square minus a perfect square, but this kind of messes you up. It's a GCF problem, okay? So you're going to take out the GCF. They both have an x. So you're going to have 0 equals x times x minus 4. T-chart it. X equals 0, so one of my roots is going to be 0. And then x minus 4 equals 0, so x equals 4. Okay, so that's one of the trick ones. If they only have the 2 terms, it's either going to be dots, like it was when we did the x squared minus 64, or it's going to be a GCF, and they try and mess with you on that one with that minus with a perfect square there, but it's really not a dots problem. Okay, I think I'm going to skip up ahead, not have you do practice while you're sitting here and turning off the camera and that sort of stuff. And I'm going to do, well, page 32. I'm not sure whether I'm going to fill in the notes or not, or let you fill in the notes. But this is what we're doing. We're solving. We're going to do solving quadratic equations by factoring. First, you get it into standard form, and y is equal to 0. You factor the quadratic into binomials, and then set the factors equal to 0 with your t-chart. Solve it, and then state it in squirrely brackets. Okay? So I'm going to do this one for you. Actually, I'll do these both for you. And first thing, you want to get it equal to 0. Like this one is not a y equals ax squared plus bx plus c. This one they kind of already eliminated that y equals 0, but they give you this. So what you want to do is bring the 3 over. You get x squared plus 2x minus 3 equals 0. Then you're going to factor that. Each get an x. Plus and a minus. Bigger is a plus. Factors of 3 aren't too tough, just going to be 3 and 1. So 3 is bigger. T-chart. I'm going to cheat here. It's just a sign flip. So you get x equals negative 3, x equals 1. So negative 3, comma 1. Okay? And then the one down the bottom, same thing. They didn't give you the y equals blah, blah, blah. They gave you just x squared equals 81. And they want you to solve it algebraically. All right, I'm going to show you 2 ways of doing it. First one, just x squared equals 81. Square root, and you're saying, well, then x equals 9. Well, that would be wrong. If you remember what I said before when we were doing with the square root of 6 and the square root of 7 when we had it earlier, last class and this previous class, or 2 classes ago, when you take the square root, you have to remember that it's going to be x equals plus or minus 9. Well, how does that happen? I'll show you. If we subtracted the 81 over, we would have x squared minus 81 equals 0. Now you factor using dots. Difference of 2 squares. Perfect square, and a minus sign. That's what we wanted. We're going to have an x plus and an x minus. And once again, the square root of 81 is 9 and 9. Don't forget your equals 0. I always forget that. Also forget to slide the paper up so you can see it. And I t-chart. X plus 9 equals 0. X minus 9 equals 0. Sign flip. X equals negative 9. X equals positive 9. Okay, so that's what we got going on there. And hopefully that will cover what I need to cover. I believe that I'm going to give you homework as this problem on 29 and the problems on page 33. So homework from the packet are going to be 29 and 33. And I should be able to come up with a delta assignment for this as well. All right, so that's our lesson for today, Monday, April 6th. I hope you are enjoying yourself and being safe and healthy. If you need anything, reach out. I'll be there. You know, it's a pain in the neck trying to figure out which comments are new and which comments have been there for a while. But we'll figure all that out and keep moving forward. And you got this, guys.